This is Chapter 9, Section 5. In this section, we're going to be solving equations with radicals. Our objective is to solve equations with radical expressions by squaring both sides of the equations. All right, so in our last couple of sections, we talked about how if you square a radical, they both cancel. For example, if I have the square root of 5 squared, the radical and the square cancel each other out. Whoops, I didn't hit the 5. But anyway, the square root of 5 squared is just 5. Because the same thing as saying the square root of 5 times the square root of 5, which is the square root of 25. And the square root of 25 is 5. So if you have a radical that you want to cancel, the only way to cancel out a radical is to square it. Well, just like all equations, whatever you do on one side of the equal sign, you have to do on the other. So we're going to square the 5 as well. So the square root of 2x minus 3 squared is 2x minus 3. And 5 squared is 25. So now we're going to solve for the x by adding 3 to both sides. So then we have 2x is equal to 28. And to solve for x, I'm going to divide both sides by 2. So I find that x is equal to 14. Now, it's important when you solve radical expressions, equations, you have to always check your answer. So you take 14 and you plug it back in for the x. So I'm going to check my answer. So I want to make sure this statement is true. So 2 times x, which is 14, minus 3, does that equal 5? Well, 2 times 14 is 28, and 28 minus 3 is 5, which tells me the square root of 25 is 5. Is that true? Yep, that's true. So my answer is correct. All right, so then for letter B, I see a radical. I want to cancel it out so I can solve for x. So I'm going to square both sides. Whatever you do on one side of the equal sign, you have to do on the other. So now the square root of 18 minus x squared is 18 minus x. And now this basically says I'm going to have to FOIL because I have a binomial. So I'm squaring this whole thing. So I'm going to FOIL it. So x times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6. So I have basically 2 of those, right? And then negative 6 times negative 6 is positive 36. So if I combine like terms, I have this. Okay? So now I'm going to bring down this. This was on one side of the equal sign, remember, and I've run out of room, so I'm just going to bring it down right here. All right, so I want to get my x's together. So I always want my x squared to be positive. So since it's already positive, I'm going to bring this stuff on this side, and I'm going to make this equation equal 0 because it's a quadratic. We always want quadratics to equal 0. So I'm going to add x to both sides. And to make this 0, I'm going to subtract 18 from both sides. Normally, I would show you that in 2 different steps, but when you go into college algebra, they're going to just combine everything in one step. So basically, negative x plus x is 0. 18 minus 18 is 0. That's what I wanted to do. Whatever I do on one side of the equal sign, I have to do on the other. So now I have x squared minus 11x plus 18. So now I need to think of 2 numbers. When I multiply them, I get 18, but when I add them, I get negative 11. This tells me the signs are the same, and this tells me both numbers are going to be negative. So negative 9 and negative 2 multiplied gives me positive 18, but added gives me negative 11. So then I want to set both of them equal to 0, because it is set equal to 0. So I'm going to set both of them equal to 0, which means I would add 9 to both sides. I would add 2 to both sides. So x is equal to either 9 or 2 or both. All right, so now, like I said, we got way off our original problem. Like I said, for all quadratics, or excuse me, for all radical equations, you have to check your answer. So we're going to go back and plug in 9 and 2 into the original problem and make sure they're both correct answers. So I'm going to go up here. I'm going to write my original problem. There we go. So I'm going to use 9 first. So I'm going to plug in 9 right here. So I have 18 minus 9 is equal to 9 minus 6. Well, 18 minus 9 is 9. 9 minus 6 is 3. Is the square root of 9 3? Yes, it is. So that tells me that when x equals 9, that was correct. Okay, remember we had two answers, 9 and 2. So now we want to make sure that 2 works. So let me give myself a little room. So this time I'm going to plug in 2 for my x's. So instead of writing the original problem, I'm going to write 18 minus 2 is equal to 2 minus 6. Well, 18 minus 2 is 16. 2 minus 6 is negative 4. And what is the square root of 16? The square root of 16 is 4, not negative 4. So that is not true. So even though we solved x equals 9 and 2, once we plug it in and find out that that gives us a negative answer on the right side of the equal sign, we can get rid of the 2. X does not equal 2. X only equals 9. So anytime, just for a hint, anytime you end up with a negative, if you have a square root and one of the answers is negative, it's not going to be a solution. All right, so my directions say to solve an equation with a square root radical expression, the first thing we're going to do is isolate the radical expression on one side of the equal sign. Number 2, we're going to square both sides of the equation. Number 3, we're going to solve the new equation. And number 4, you always need to check each solution of the new equation in the original equation and eliminate any extraneous solutions. In other words, solutions that make it not true. All right, so letter A, on my directions I just read to you, the first thing it says is to get the radical expression by itself. Well, 2x plus 5 is under the radical, but plus 3 is not. So I'm going to get rid of plus 3. So the only way to get rid of plus 3 is to subtract 3 from both sides. So now I have square root of 2x plus 5 is equal to 15. Now I want the radical to go away, so the only way to get rid of a radical is to square it. Whatever you do to one side of the equal sign, you do to the other. So the square root of 2x plus 5 squared is 2x plus 5 is equal to 15 squared. So 15 squared is 225. I'm going to subtract 5 from both sides. So my answer, well, so far, is 2x equals 220. And then when I divide by 2, I find out that x equals 110. All right, so now I'm going to check my answer. So my original was 2x plus 5 plus 3 equals 18. Let's make sure that's true. So 2 times 110 plus 5 plus 3 equals 15. I want to make sure that's right. So 2 times 110 is 220 plus 5 plus 3 equals 115. This says 225 plus 3 plus 15. Well, the square root of 225 is 15. Guys, I changed this from an 18 to a 15. I'm sorry. If I don't write it right, I'm not going to get the right answer. All right, so anyway, the square root of 225 is 15, and does 15 plus 3 equal 18? Is that true? And yes, it is. So we know when we found out that x equals 110, since we checked our answer, we found out that was correct. That gave us a true statement, and so our answer is true. We have a good solution there. All right, so letter B, everything's under the radical. So to get rid of that radical, we're going to square both sides. All right, so if I square a minus 3, if I square it, I FOIL it, remember? So a times a is a squared, and then I'd have negative 3a minus 3a. Well, negative 3a minus 3a is negative 6a. Negative 6a. And then negative 3 times negative 3 is positive 9. All right, I want my a squared to be positive, and it is, which means I'm going to subtract 3a from both sides. And I'm going to add 9 to both sides. All of this would cancel. I would get 0 on the right side of the equal sign. Over here I have 2a. Negative 6a minus 3a is negative 9a, and 9 plus 9 is 18. I want two numbers. When I multiply them, I get 18. When I add them, I get negative 9. This tells me that my signs are the same. This tells me both of my signs are negative, so that'll give me negative 6 and negative 3. When I set both of these equal to 0, what will happen? We're going to get the opposite answer. So we found out that a is equal to both 3 and 6. So we want to check our answer, make sure they're true. So I'm going to use my 3 first. I'm going to plug in 3. So I'll go back to my original problem, a minus 3 equals the square root of 3a minus 9. So I'll plug in 3, and then over here I'll plug in 6. So 3 minus 3 is 0, and then I'm going to multiply 3 times 3 minus 9, 0. 3 minus 3 is 0. 9 minus 9 is 0. Is the square root of 0, 0? Yes, it is. Oops, I ran out of room, but yes. So 3 is a good answer. 3 is a good answer because this is true. All right, let's now try for 6. So we're going to plug in 6 for a. So 6 minus 3 is equal to the square root of 3 times 6 minus 9. Well, 6 minus 3 is 3. 3 times 6 is 18. 18 minus 9 is 9. And the square root of 9 is 3. So we actually have two solutions. Since that is true and that is true, both of these are good answers, both of them. Okay, so we didn't eliminate anything in this one. We got two correct answers. All right, letter C. We have the radical by itself, so we're going to square both sides to get rid of that radical. So the square root of x plus 1 squared is x plus 1. Negative 3 squared is 9. So all I have to do to solve for x is to subtract 1 from 9, and I get 8. All right, so we got to make sure we check it. So I'm going to plug in 8 for that x right there. 8 plus 1, does that equal negative 3? Nope. The square root of 9 is not negative 3. So we're going to write no solution. Square root of 9 is 3. All right, and letter D. Now this time we have radicals on both sides. To get rid of a radical, we square it. Well, what's going to happen on this one is they're both going to cancel. So the square root of 9 plus y squared is 9 plus y. Y plus 9. Square root of 3y minus 3 squared is 3y minus 3. So we're going to get rid of one of the y's. So we have 9 equals 2y minus 3. I'm going to add 3 to both sides. So I have 12 is equal to 2y. I divide by 2, and y equals 6. So then I'm going to plug in and make sure I got the right answer. So if y is 6, I'm going to write 6 plus 9 is equal to 3 times 6 minus 3. Just plugging in 6 for y. So 6 plus 9 is 15. 18 minus 3 is 15. We don't have to go any further. We know that the square root of 15 is equal to the square root of 15. So that means that 6 is the right answer. All right, so try the next 4 on your own. I've given you the answers. Go ahead and try those and then come back to the video. And if you have any questions, see how I solve them. If you get them all right, you don't need to watch me and you can go ahead and do your homework. All right, so for number 1, we're going to square both sides. So for number 1, I have x plus 5 is equal to 36. I'm going to subtract 5 from both sides. And x is equal to 31. When I plug it back in, 31 plus 5 is 36, and the square root of 36 is 6. So that is the right answer. So number 1, the answer is x equals 31. Number 2, I'm going to square both sides. So I'm going to have the square root of 4x plus 1 is 4x plus 1. Equals 81. I'm going to subtract 1 from both sides. So I'd have 4x is equal to 80. And then when I divide by 4, x equals 20. So then when I plug in, wait, that's not right. It's 40. I'm sorry. All right, so then if I plug in 4 times 40 is 160. Wait, what did I do? Oh, it is 20. I'm sorry, I'm all confused. Did I do that right? 81. And then 80 divided by 4 is 20. And then 4 times 20 is 80. Yeah, I don't know. I've lost my mind, you guys. All right, anyway, this is 20. Because if 4 times, I'm going to multiply 4 times 20. 4 times 20 is 80. And 80 plus 1 is 81. The square root of 81 is 9. So, sorry. I have a brain meltdown. Yes, so number 2 is 20. That's correct. Oh, my goodness. Hopefully, y'all aren't not watching this. All right, so number 3, if I square both sides, this is number 3, I'm going to get 2x minus 5 is equal to negative 1 squared is 1. So then I add 5 to both sides, so I get 2x equals 6. If I divide by 2, I get x is equal to 3. So then, like all problems, I have to check my answers. So if I plug in 2 times 3 minus 5. I want to see if I get 1. Well, 2 times 3 is 6. 6 minus 5. Does 6 minus 5 equal negative 1? Nope, it equals positive 1. So we have no solution. Number 3. Number 3 is no solution. And then finally, number 4, we have to square both sides. So I'm going to do this over here. So I'm going to square this. So I have x plus 1 squared. So x plus 1 squared. So x times x is x squared. Then I'd have 1x plus 1x is 2x. And then 1 times 1 is 1. All right, I want my x squared to be positive, so I'm going to move my 10x and my 21. And both of those will cancel, so I'll end up with 0 on the right of the equal sign. So I have x squared, and then 2x minus 10x is negative 8x. 1 combined with negative 21 is positive 20. So then I'm trying to think of 2 numbers. When I multiply, I get 20. When I add them, I get negative 8. This tells me the signs are the same. And this tells me my sign, both signs are negative. So that's going to give me, let's see, What would that be? 20 would be 1 and 20, 2 and 10. Oh, it's negative 20, you guys. Oh my goodness. I hope no one's watching this. Anyway, this is negative 20. So it's going to be negative 10 and positive 2. Negative 10 and positive 2. My bad. I brought down my wrong sign. All right, so then if I set x minus 10 equal to 0, then I would find out that x is equal to positive 10. And if x plus 2 is equal to 0, my other solution would be negative 2. Like always, I want to plug them both in and make sure I have good solutions. So my original problem was x plus 1 is equal to 10x plus 21. So if I use 10 first, 10 plus 1 is 11. And then I have 10 times 10 plus 21. So 11 is equal to the square root of 121. And that is correct. The square root of 121 is 11. So 10 is a good answer. Now I'm going to try negative 2. So if I plug in negative 2 plus 1 is equal to 10 times negative 2 plus 21. So negative 2 plus 1 is negative 1. This would be negative 20 plus 21, which would be positive 1. Is the square root of positive 1 negative 1? No, it's not. I'm going to get rid of 2, and my only solution is x equals 10. X equals 10, because when you check it, you find out that the 2 doesn't work. Okay? Sorry about my huge mess. Hopefully you guys worked a little neater than I did. All right, and you guys are done with chapter 9.